Hello, let's take a look at your MT11 LT8 seminar on modeling. First thing I want you to do before we get started is work in your table groups and do the first 5 questions. But working ahead, do the first 5 questions and then hang on to them so you can work with your table groups when we get to them. What we're going to be looking at today and doing is we're going to look at the difference between linear, exponential, and quadratic. We're going to kind of put the whole year together. Remember, linear is a line, exponential is a curve with x as the exponent, and quadratic is what we've been studying. And then we're going to make and evaluate predictions by fitting nonlinear functions to real-life data. So we start here. Remember, linear is y equals mx plus b. Quadratic is ax squared plus bx plus c. And exponential is a times b to the x. We can tell it from a graph because linear is going to be a line. Quadratic is going to be a parabola. And then we have our exponential curve here. We can tell some information. We know in a linear model, our first differences are going to be equal. Quadratic, as we're going to learn today, that's going to be our second differences are equal. And then we know exponential, our ratios are equal from before. We can use that. Our first difference in a linear equation is going to be our slope. Half of your second difference in a quadratic is going to be a in ax squared. And then my ratio is going to be b when we do that. So let's apply that to example 1 here. In fact, I think we're going to look at each one of these and see what happens. First thing I like to do is I like to do exponential first because it's either really easy to find or it's very easy to eliminate. So if I take -1 times 4 gives me -4. But if I take -4 times 4, do I get -7? No, I don't. So it's not exponential. So we're going to throw that one out right away. No. Let's look at our differences. Notice first off, I can't do this unless all my x's go up by the same amount each time. In Algebra 2, you'll learn how to do that when they don't go up at the same amount of time, but that's where we're going to be limited to here. So from -1 to -4, it goes down by 3, doesn't it? From -4 to -7, it goes down by 3. From -7 to -10, it goes down by 3, goes down by 3. So this is a linear model. I can represent this with y equals mx plus b. In this case, I know my slope is -3. I'm going to pick one of my points on here. And I don't care which ones you pick. I like the first one because I like working with smaller numbers, but it doesn't really matter. So in other words, y is -1, m is -3, and x is 5. I could do that with any pair of points I wanted to. I could use 6 and -4, 7, -7, and so on. Now let's solve this. So -1 equals -15 plus b. Well, we'll add 15 to both sides. And b is 14. So this table can be represented with a linear equation. And my linear equation is going to be y equals -3x plus 14. And there is our linear model we can do for the first one. Let's take a look at example 2. Now, right away I can eliminate exponential because notice I can't multiply anything by -1 to get 0. It's just not going to happen, so it's not exponential. So let's start over and let's look at our differences. From -1 to 0, looks like I'm going up 1. From 0 to 4, I'm going up 4. This is not linear, is it? Because they're not the same. Let's keep on going, though. From 4 to 11, I'm going up by 7. And from 11 to 21, I'm going up by 10. Now let's look at those differences. From 1 to 4, I'm going up by 3. From 4 to 7, I'm going up by 3. 7 to 10, I'm going up by 3. This is what we call second differences. So that tells me this is quadratic. Quadratic has the form y equals ax squared plus bx plus c. Now, first thing we notice, or hopefully we notice, from our table, half of my differences is a. In other words, I know a. A is 1.5, because half of 3. 3 divided by 2. Let's look for my y-intercept, because I know my y-intercept is c. My y-intercept occurs when x is 0, because that means the y-intercept. Where does it cross the y-axis at? It crosses at 4. Then I'm going to pick one of my other points. I like 1 and 11, but any of these would work. So now I'm going to replace y with 11, a with 1.5, and x is 1. I don't know b. That's what I'm really looking for. I'm going to multiply it by the same x, and I know c is 4. So we get 11 equals 1 squared is 1 times 1.5 is 1.5 plus b plus 4, or 11 equals 5.5 plus b. Well, minus 5.5 from both sides, and notice b is 5.5, isn't it? Kind of weird that one worked out that way. So 5.5 is b. Now, you might, on your computer, they might require fractions, so let's write this as a fraction. So a is 1.5, which is actually 3 over 2 then, isn't it? 3 over 2 x squared plus b, we just said, was 5.5, which is 11 over 2 x plus 4. Now, some of you tried to cheat back when we did the quadratic, or when the exponential parts, and were giving me quadratic equations. I know you were just looking things up. You weren't even thinking, because I never taught you how to do this, not even close to it, and you were giving me these answers. You either be honest and do your work in your notebook or on the board, or I'm going to require you to show your work. I'm not going to accept any answers unless they have work showing. I would prefer you to be honest. But if you can't be honest, we're going to start handing in the work for the remainder of the year on every single problem, and I won't count it right unless you have your work. So please be honest.